I'm going to show you how you can create this simple pattern using Substance Designer. We'll be focusing on just this pattern and nothing more. We'll start from a brand new project and I'll show you some tips and tricks on how you can use that to begin to create patterns, and we'll just build upon this tutorial from there on. So buckle your seatbelts, get your coffee, and let's begin. So when you start up the program, just go over here and create a new substance graph, and we'll actually create an empty graph, and I'll show you why in a second. So here we're just going to call this our shape, and we'll click OK. So we have a blank and empty Substance Designer project. So now when you do that, I'm going to go over here and reset the window. So it goes reset layout. I'm going to restore to the default layout. I'll just click yes, so that this layout and my layout will all have the same layout. Now just drag this view right here. So what I like doing is having these shared with the same window. Basically the Explorer window, I want to share that with the library. So just click and tap where it says the rounded cube here. Just click and drag that. Let's just drop that here with the Explorer. And for the 2D view, let's share that with the library. So down here and left click, and that's it. In case you make a mistake, remember you can always go to Windows and go down to Reset Layout and you'll be good to go. So we have a blank, empty node view right here, this instance window. And we'll see an error here at the bottom that says no output node defined. Well, Substance Designer is a texture altering program. Use that to alter textures and materials, tileable textures and materials. That's the main end goal of this program. If there is no output, it doesn't know what you're talking about. So a very good material to use when you're starting off is to use the base material. And so go to your library here and go to the search and just type base material, and you should have a base material here. Just left click and drop the base material here in the window so that we can instance this base material. So right here on the right side of the screen, this is the properties window. Anything we have clicked is going to show us the properties. And now we can see the cube. This is a 3D view and this is the 2D view. So we don't have anything applied. We want to apply this base material to our cube. So just right click on it, drag, and left click and release. Now we can actually see something going on. We can see our cube being reflective and it's looking a bit metallic, if you might say. So why is it doing that? Let's go over to the base parameter, the base properties of this base material. Make sure you're selecting that material so you can see those base properties. So here we can actually see we're working with the PBR workflow, a metal roughness workflow. We can change this to specular glossiness, but I'll just leave this as metal roughness. So what is PBR and what does it mean? What is this confusing term? So PBR simply means a physically based material or physically based shading, and basically it's a method or a system that renders realistic lighting. So basically if you have an object in a room, an object outside, an object at night, an object in the evening, an object when it's raining, depending on the lighting setting, that object is always going to remain having a consistent lighting. So it's actually a very good concept, and you can use this to create different lighting scenarios without creating different textures each time for each setup. So hopefully that wasn't too confusing. That's what PBR means. It just means you're using physically based shading. Now the metal roughness workflow is assuming that an object can either be a metal or a non-metal. And when an object is a metal, it uses a value of black and white to tell it if it's a metal or a non-metal. For example, here on our metal roughness workflow, we can actually notice this object here is looking slightly metallic. That means there is a value that's assigned to this. Let's see how we can make this object look like a non-metallic object, like a tree trunk or a brick, for example. So let's use a brick, for example. So here we have some user-defined maps here, and remember textures are called maps. The base color is the base color of the object. So if we turn this to true, we actually notice there's an input slot right here for a base color. We need to supply a way for Substance Designer to understand what kind of input we want to plug into this base material. So over here at the top, you can actually notice this fill tool that looks like some, paint dropping out of it. Let's click on that. That's a uniform color and the color is black. If we plug that into the base color, we actually notice it's black. Let's try changing the color. You can click over here on the output color and let's set this to a blue material. It looks like a blue metallic object. So nice. So base color or albedo in some other applications is just basically the reflected diffuse color. When light falls on an object, it absorbs the colors of the other wavelengths and reflects the wavelength, and that gives you this blue color. So the wavelength of this blue color is what is being reflected, and we can see this as blue. And remember, we can always click on that and change it. Now the properties panel is context sensitive. It means if I click on the base material, I'll actually see the properties of the base material. So let's go ahead and talk about that metallic thing we discussed, where I said we can use a value of black and white to specify whether an object is metallic or it's non-metallic. Over here on metallic, I'll just click on that to make it true. Now we can see it wants this color is grayscale, but this color is orange or yellow, if you might want to say. So basically in Substance Designer, whenever you see an input that has a orange value, it means it can accept a color value. That's why we are able to color this. If we can see this input here where it says metallic, let's try putting a color value to this. So I created another uniform color. I'll set this to any color. I'll set this to blue. And what I'm going to do is just connect that into the metallic slot and we get an error. This red line means, oops, I'm not really understanding why you're trying to provide a color into a grayscale input. Well, to do that, on the uniform color, change the color mode to grayscale, and Substance Designer is happy now. So over here on the output color, let's drag this towards white like that. And now when we drag this towards white on the metallic slot, we see this object is very metallic. It's looking like a metal. And when we drag this object towards black, it means this object is not really metallic anymore. It means it's a non-metal. So that's one way we can use that to describe whether an object is metallic or non-metallic. Now, again, when light falls on a very polished surface based on the principle of index of refraction of light, it means the angle at which light is bouncing off an object is very clean. There's no breakaway of that light source. So an object is going to look very polished, and that is controlled by the roughness. So let's click on our base material and let's go over here to the roughness, and I'll turn that map on to true. Now it needs a roughness input. Now a roughness input would always also use, now when you see what happens when we turn on the roughness, we can actually see our object looking very polished, and we can see the environment that's lighting up this 3D view, by the way. So Substance Designer has environments, and these environments actually control how the object is looking like. So remember, we said we were using a PBR environment, right? We're using a PBR base texture, and this is just telling us how this environment is being lit, and this is the HDRI image that is lighting up our 3D object. So that's just by the way, I just wanted to point that out. So when we plugged in roughness, it looked very shiny, which means it's a very polished object, and we can see it here. To specify a roughness value, let's make this surface a different object. Say maybe there's dirt on this surface and it's breaking away this light. So to do that, let's add a uniform color. And let's plug that into the roughness input and change that into grayscale. I will see, for example. So a value of black means this object is very, very smooth. There's no roughness here. But when we begin to drag this value up, we can actually see the surface being rough. That means it's breaking up the light. The angle at which the light is landing on this object is being scattered. So the more we push this towards white, it means this object is, very rough like that. So the surface is very rough. We're not seeing any specular reflection. So that's something you should notice. So if you're working with things like water, you could just turn this down a bit, right? So it depends on what object you're creating. So we're creating a non-metallic thing like a brick. So we'll turn up the roughness. Because if you think about it, a brick will not be shiny and reflective. So these are our basic map, our video. We've seen our metallic roughness. We've seen our metallic. Let's go ahead and create the height and the ambient occlusion. So a height map, let's go ahead and turn on the height map. So a height map would usually accept a grayscale value, a black and white value, and it will use the black spots to know how, dipped in an object is, and white spots to know how pushed up or outward an object is. And a normal map also does similarly the same thing, but with a normal map, what it does is use more of the tangent space, or, the how angled an object is, and basically uses more math. To properly use a normal map, we'll use a normal input in the input slot. So over here where we see this purple logo looking bluish, we'll just pass in that input to our normal. And if we want to see what the normal is doing, usually we bump the intensity to about maybe say 8 to see that. So any object we plug into the normal, we'll see that intensity. Don't worry, we'll actually plug that into the normal slot. Now for the height map, let's go to our base material. For the height and ambient occlusion, so ambient occlusion is going to simulate light in crevices, in corners where light usually isn't getting through. It adds more realism to this, and to properly simulate ambient occlusion, we use another node called the horizon-based ambient occlusion. So I'll hit the space bar, and mind you, you can find most of these atomic nodes, which are these nodes at the top when you hit the space bar. So what I'll do is just type AO, or I'll just type ambient. For some reason it's not working, so I'll just try ambient. There it is. So I'll use the horizon-based ambient occlusion. Now there are two types. There's the HBAO and the ray traced ambient occlusion. HBAO is more memory efficient, so we'll use that. So we'll pass this into our ambient occlusion slot. And since it's using, it'd be nice to share that same input. So what I'll do is to use a basic blur node, and I'll just drag the blur node. I'll undo that first and select anywhere, and I'll drop in a blur node and just place that blur node right here. So basically I'll drag the intensity down to 0. So basically I'm using this blur node as just an input and output channel. So it's just getting an input and output. And I'll pass the normal over here, and I'll also pass the ambient occlusion, and I'll also pass this into the height like that. Now this is seriously complaining, so what we're going to do is just get a base uniform color and pass that here, and we'll turn this to grayscale, and we should be good to go. So basically, if we have any object, we'll pass this single object and we'll get the output of the normal, ambient occlusion, and the height, because they're all sharing the same input here. All right. Okay, super duper cool. So let's use a shape to see our output here, what's happening here. And I'll change this to a neutral color like gray, like that, just a mid-tone gray, just to get rid of that color information. And what I'm going to do here is hit the space bar, and I'll search for a shape and bring in that shape. So once we have that shape, I'll pass that shape into the blur, and we can get rid of this uniform color. And what we'll do is to drag down the scale. So I'll just drag this down a bit like so. So on the 3D view, we can see that shape on our 3D object, and we can see the 2D view here. Now we actually have height data, and we want to really see that information. So on the material, we'll go to materials right here and go to edit. And when the edit panel opens up, we'll just go to our height and turn up the tessellation factor and bump up the height scale a bit. Now what's happening is you can actually see how this object is really looking here. It's looking more 3D. And we'll just drag up the tessellation factor to make this slightly, smooth like that. We'll drag this down. I'll set this to about 11, and that's it. I'm just leave it like that. That's super fine. So we can actually see our normal output over here. And let's set this to, we can leave that on DirectX so we can see our normal output. We're not getting any output yet, so we need to create our output so that we can be able to export this material right here. And we can pass this to, okay, we have this roughness input, we have everything. So let's create our outputs. So here, let's drop in an output node and connect the base color output, and we'll create an output for all our materials right here. Like so that we can be able to export them and use them. So we didn't use the metallic. Okay, we used the metallic. Fine, no problem. We'll just create an output for each and every one of our materials. Click the output like so. We'll drag this to the height, and the output for the ambient occlusion, we'll just drag this over here. And it's good to rename them so that you can literally know what the output is. So I'll just call this the AO, and like that. So this is our base color. So I'll just call this the albedo. So I'll just take a few seconds to name each of these. So this is our normal. I'll just call that N and be a bit lazy. Let's call that N. Here's our output. For roughness, I'll call that R. Let's click away. Sorry, this is our normal N. And this is our R roughness, and like that. So, and yeah, so that's how we can just give out names to these outputs so that when we export them, we won't be confused what they are and what they do. So let's create that star shape we saw at the beginning. So I have this basic shape node, and this is a node, by the way. It's just a collection of, components that are used to create variety of filters, effects, shapes, and textures. This shape node has a pattern property where we can change this. So if I change this to a disk, notice we now have a disk shape. If I click on this, we can see the 2D and 3D view. So I'll set this back to the square shape. So now I have that square shape. I'm going to use another node to change or distort this shape here. And the one I'm going to use is slope blur. So I'll just search for slope blur grayscale because I'm using grayscale values here. And this node actually has a samples property and an intensity. And it also needs a feed here for the slope. So this is going to require an input, and then we can pass that data into this. Now what I'm going to do is to just hold shift, and I'll just drag this here and connect this here and take the grayscale input into here. And we can see there is no difference at all. So let's see what we can use to distort this shape. And this is where the fun actually begins. So we can either go to our library. I'll just hit the space bar and search for, let's try a noise. Or let's add another shape here. So I'll just go to this shape and hit Ctrl D to duplicate this shape. And what I want to do is to blur this shape based on a grayscale value because we can't really see anything here. It needs a slope, which basically means a transition, a gradual transition from one value to another value. And in this shape, let's try the bell. So we click on this. This is what we get. Let's try a paraboloid. So I think the bell is a nice one to try. So let's go back to the bell, and I'll increase the scale to about 1 to increase that shape. And you can see what it's actually doing, right? We can look at our shape and see what's happening to our shape right here. We're getting a buffed look. It simply means if we turn this negative, so let's go back to the shape. Let's go to the intensity, and let's set this to a value of 16. So now we can see that shape, that bell shape here is pushing our shape here, is distorting our shape here. So let's try something like -40. like so. And you can see what we have here. So we're creating these fun, interesting shapes like so. And it's using that based on this fall off of this grayscale shape here, this one here. Now, another interesting node to actually use, and we can play around with these samples. I'll set this to about 32 samples, and it gives much more smoother detail like that. All right. We can also change the mode to a minimum, or we can set this to a maximum mode. And that will give us an output and also gets rid of that detail in the center. I'll just set this back to blur mode so we can beat at this default mode right here. So another interesting node we can use, for example, if you just want to get this grayscale data, this black and white data like we have, something very flat like that, we can use the threshold node. So let's go hit the space bar and search for threshold. So let's go over here, library, let's search for thresh. That's strange. Let's see. I believe I was spelling it wrong. Yeah, that's how you spell threshold. Shame on me. I can't even spell. And what we want to do is to use this threshold node. So I'll go over here, plug this in and drop this in here. And now we can see our threshold node is just giving us back our information here. So what we can do on our slope blur is to, kind of drag this down more. And I'll set the intensity to about -96. And you can see we have this shape here. And again, don't be afraid to crank up these numbers. I'll try -150 like that. And this is actually pushing this further in the more we, drag that. And if I drag this up, we're getting this back here where it's pushing it outwards. And here it's pushing it in till we get a shape like this. Right. So I'll just set this to about 150-ish to get this star shape. So now we actually have this base shape. Let's say you're happy with this star shape. How do we play around with this star shape and create much more interesting or integrate details and patterns? Well, the first thing we can do is to duplicate this entire base here. This is our base, and we can add a frame. I'll click on this. This is a frame, and we can call the frame our base. So I'll just call this base over here. And we can even set a color. Let's use a green color for the base. And what we can do is to duplicate this entire node set. So I'll use Control D. I'm sorry, with this selected. Let's just select all this like so. So I use Control D and just drag this set, and I place this set here. And all I want to do in this set is to first transform this. So I'll use a transform 2D node to change how an object looks like. So I'll just double click on this to be on the transform, and I'll connect this into the input. And what I want to do is to rotate this 45 degrees. Now we'll take the rotation here. I'll set this to say 45, and this will rotate our shape to 45 degrees. And so what we can do now is to begin to combine our shape. So I'll drag all this, select all this, and push everything away to the side so we have a little space here. And what I want to do is to combine these two shapes together. So I'll go over here to one of the most important nodes, which is the blend node, and I'll combine A and B. So I'll set this to the foreground, and I'll set our blur shape to the background. And if I want this entire output to be, here, what we can do is to hold shift and then drag this over here, and this will switch over this connection. Now we're seeing this shape on the foreground, but we can't see the shape on the background. And what we can do is to change the different blending modes. So this is on copy. Let's try something like add. And this is now combining these two shapes. And what's happening right here is we're getting a star shape by just adding these two shapes over here. If you wanted to do something interesting, and basically all it's doing is taking this pixel data and combining it with this pixel data. If we use subtract, it's going to cut out. So let's see over here. Let's go to subtract, and this is going to cut out these two shapes, and we'll be left with this shape here. So what we can do now is to maybe create another shape in between to represent these shapes, right? So it depends on what you want to do. So I'll leave this back on add. And what I want to do is to create another shape. So I'll go over to shape here, hit Shift D, Control D to duplicate that shape, and I'll just place that over here, right? So I'll drag these two over here to the left. Now what we're doing is from left to right, we're going to be adding more information. So we started with this shape, our base shape here on the left. I'll just drag this, drag our base shape on the left. And now we're combining our base shape with this, right? And now what we're going to do is to take this new shape and combine it with another shape. So here under the shape, I'll set this to a disk. Will give us a circular shape like so. If I double click on it, I can see this. So now what I want to do is to create another blend mode. So I'll click on the blend mode right here and now set this to the background. So I'll just drag all this, place the output here, and I'll take this output, set that to background. I'll set this to the foreground, and I'll set this to subtract. So now you can see it's actually subtracting that circular shape right there, and we're getting a nice radial shape like that around. Now what we can do is to reduce the disk size by the scale. So I'll just drag the scale down a little bit so we can have a nice little punctured hole in the center if that's what you want. So you can see we can always play around with this and we can drag that. So let's say we want another circular shape in the center. You guessed it, we can easily do that by using the same principle. So I'll drag this further away. And right here, what we're going to do is to duplicate this. So I hit Control D by selecting on that shape and placing it right here, dragging this over here. And I'll duplicate this blend node here. So this one is actually on subtract. So I'll hit Control D and duplicate that node here like that. So I have a shape node. I'll connect this here as my input, and the input is going to be this input now. And then for our output, I'll hold Shift and connect this like so. And what we'll do is, rather than set this to subtract, we'll leave this on our copy, or let's leave it on add. So this blend mode is on subtract, this is on add. So what we want to do is to scale this one right here. So let's scale this down a bit and see what we have here. So we have a circle in the center now, and what we can do is to play around with that circle. So I'll just begin increasing the size to about, any size we want, like so. And we can actually see this nice little sunflower pattern here on our object, right? And you can use this. So you can see what we're doing here. We just started with a base shape. Use these thresholds to determine how this should look like. We can play around with the threshold value. Set this to about, 96. And you can see now we're getting a nice little star shape like that. For this threshold value, we can do the same thing here. We can drag this amount, so about 45. Can drag this down like so. And we can literally play around with this to get any combination of interesting shapes we want to use, like that. So now we have our star at threshold 0.11. We can see we have this spiky shape and basically any design we want. We can also do things like go to our initial base shape and we can change the X and Y size just to play around with that so we can see what it's doing. It's just increasing that. The pattern size, we can go to this one. We can drag the Y down like so. Let's play around with this and we can see our output. We can also play around with the rotation manually by just dragging this around like that, like so. Yeah, and basically that's how you can create a nice base pattern with these parameters you can play around with. And then when we're done, we can start doing things like using a scattering node to actually organize this. For example, if I hit the space bar and I look for a tile generator and just place the tile generator right here. So it needs a pattern input. So we'll use this as our pattern input. And under the pattern, we'll just set this to image input, which is going to be our base pattern here. And what we can do is to take this output and connect that into the input. And now you can see we have a nice little pattern with these bricks. Now, apparently that height is too strong, but no problem. We can use this. We can just play around with this. So with the tile generator now, what we can do is to reduce the X and Y amount. I'll set this to about 6 by 6, like so. Just so we have a nice little 6 by 6 grid and just see how that looks like. And we can start doing things like playing around with the color and all that. Also, on the pattern input number, I'll just scroll down here and begin to play around with things like the offset. And this is where it gets interesting. With the offset, for example, we can just offset our tiles to make it non-uniform. And I'll set that back. We can play around with the global offset as well. So for the X and Y global offset. And we can always set the scale. Like so. We'll just drag this over here. And this will increase the scale of our object. And this really pushes this design to create very nice, interesting details like so. All right, guys. So in our next set of lessons, we'll learn how we can begin to create and apply some patterns to this. But I hope this gets you started with Substance Designer and actually realize that the program isn't really as scary as it is. The only thing is there are a lot of parameters, and each parameter can quickly, change how an object really looks like. Thanks very much for watching, guys. I hope you learned something about Substance Designer, and I hope you're going to have fun playing around and creating your own fun little patterns. See you guys in the next lesson.